So, what if the fastest way to build a godlike artificial superintelligence, ASI, isn't by teaching it to think like a human?
Right, like what if that's actually the worst way to do it?
Exactly. What if ensuring it has absolutely no idea what a human even is the actual shortcut?
It's a crazy thought because, think about the narrative we are fed every single day, right?
Oh, constantly. You track the massive investments from like OpenAI, Google, Anthropic.
Yep, billions of dollars.
Brilliance, yeah. And the implicit goal is always to build a digital brain that essentially mirrors ours.
We expect it to do everything. We want it to write poetry, interpret a legal contract, understand the nuance of a sarcastic joke.
Drive a car, plan a wedding.
Exactly. The ultimate finish line is always treated as this massively upgraded human mind.
Right, but why? I mean, why is that the default?
Well, we are just projecting our own biological evolution onto silicon
Mm,
because, our specific type of generalized intelligence is literally the only framework we have ever known.
that's all we have to compare it to.
Right. So we have this massive cognitive bias. We just assume the path to ultimate machine intelligence must traverse the entire landscape of human experience.
Like it's some sort of unavoidable checkpoint.
Exactly. We treat human-like understanding as a mandatory pit stop on the way to superintelligence.
Well, today's deep dive takes an absolute sledgehammer to that exact assumption.
Yes, it really does.
So, the creator of the notes we were working from ran this brilliant experiment. They took this premise that attempting to build artificial general intelligence, or AGI,
The human-like stuff.
right, the general stuff, that trying to build AGI first is actually a catastrophic detour. And they pitched this to 5 of the most sophisticated AI models currently in existence.
And the prompt was actually pretty simple, right?
Super simple. It just asked them to argue against the conventional AGI first approach and, make the case for an ultra specialized shortcut instead.
And the lineup of models they queried is basically a who's who of current frontier tech.
Oh, yeah, heavy hitters.
We're talking Gemini 3.1, GPT 5.2, Sonnet 4.6, DeepSeek R1, and GLM-5.
And every single one of them
Every one of them.
was asked to outline how we reach artificial superintelligence, ASI, much faster through a concept called ANDSI.
Right. Artificial Narrow Domain Superintelligence. ANDSI.
Right. But before we unpack the actual mechanics of ANDSI, I have to mention this quick little detail from the source notes because it's just too good.
Oh, the Grok thing.
Yes.
Hmm.
The creator actually tried to include a 6th model in this debate, Grok 4.
Right.
But Grok repeatedly timed out. It just kept failing to generate a response because of server overload.
Which is pretty funny.
Our source left this highly sarcastic little note theorizing that XAI must be seriously strapped for compute cache right now.
It's a perfect ironic illustration of the physical hardware constraints we are dealing with today.
Which, ironically, happens to be completely central to the ANDSI argument we are about to discuss.
Exactly. Hardware limitations are a huge part of this.
So let's define the battle lines here. If you're listening to this and you're just, overwhelmed by the endless think pieces debating whether an AI is conscious,
The consciousness debates.
Ming
Doesn't
arrow.
end.
or if it truly understands us, this deep dive is going to be incredibly refreshing for you.
We are completely bypassing all of that philosophical noise today.
100%. The argument presented by these 5 models operates on pure, brutal, algorithmic efficiency.
No philosophy, just math and engineering.
Exactly. And they all agree on one foundational premise, which is that the requirement of human equivalence is the single biggest bottleneck in AI research right now.
Yeah, Sonnet 4.6 and DeepSeek R1 both frame this as a massive problem of scope.
Explain that, like the scope problem.
Well, the scope of AGI is just staggering when you look at it from an engineering perspective.
Because it has to do everything.
Right. To actually qualify as an artificial general intelligence, a system has to match or exceed human competence simultaneously across every cognitive domain.
So not just text.
No, everything. That includes natural language processing, spatial reasoning, visual perception, fine motor control via robotics.
Emotional intelligence.
Yeah, emotional intelligence, abstract creativity, you name it.
And DeepSeek R1 used this brutal phrase for this requirement. It calls all these diverse human tasks research sinkholes.
Research sinkholes, it's so accurate.
It really is. Think about what happens under the hood when you ask a frontier model to plan like a 5-day vacation to Cabo.
Oh boy.
Right. Including booking the flights, finding an Airbnb, and anticipating the social dynamics of the friend group you're traveling with.
You're forcing the model to allocate literally billions of parameters to understanding highly subjective, nebulous human constructs.
Right, like who gets the master bedroom?
Exactly. To an AI tasked with the ultimate goal of optimizing intelligence, interpreting a metaphor, or predicting a flight delay are computationally irrelevant.
They're useless skills for a supercomputer.
Completely useless. They do not contribute to the system's ability to design better silicon.
Yeah.
They don't improve its capacity to write more efficient sorting algorithms.
So, okay, let's map this out with an analogy because the inefficiency here is wild.
Definitely.
Imagine you have a team of elite engineers tasked with building a world champion Formula One car.
Okay, pure speed.
Right. The singular goal is raw speed on a closed track. But halfway through the design phase, the investors demand that this F1 car also needs to seamlessly parallel park on a steep hill in San Francisco.
Which completely ruins the chassis design.
Exactly. Then they add a requirement that it must comfortably seat a family of 4, complete with a trunk for groceries.
And don't forget the aerodynamic cup holders.
Yes, the cup holders. So suddenly these engineers are forced to compromise the entire aerodynamic profile to accommodate a trunk.
They have to add weight to the suspension for the family of 4.
And the vehicle basically becomes a bloated minivan trying to compete in a Grand Prix.
That is a brilliant way to put it. The cup holders and the parallel parking sensors are adding massive compute overhead.
Right. If the goal is pure speed, every single ounce of energy spent perfecting the cup holder is wasted momentum.
And Gemini 3.1 really leans into this heavily. It states that perfecting these human-centric traits forces researchers to constantly battle the brittle nature of multimodal AI.
Multimodal meaning handling text, audio, and video all at once.
Right. Gemini makes a crucial technical point here about parameter dilution.
Parameter dilution. Okay. Unpack that.
So when you train a single neural network to process visual data, audio data, and text simultaneously, you encounter a phenomenon known as catastrophic forgetting.
Catastrophic forgetting. That sounds bad.
It is. It means the network learns a new rule about physics, maybe, but in doing so, it literally overwrites a subtle rule it had learned earlier about conversational etiquette.
Oh, wow. So it gets smarter at math, but forgets how to be polite.
Exactly. Researchers spend years building complex architectures, like a mixture of experts, just to keep the model from unlearning how to do calculus while it learns how to write a sonnet.
It's just a constant tug of war.
Yeah. And GLM-5 expands on this with a concept it calls the broad compatibility problem.
Broad compatibility.
By forcing a model to be broadly compatible with the messy, illogical reality of human existence, we are basically artificially handicapping its processing power.
Right, because humans are messy and illogical.
Very. GLM-5 actually refers to AGI as the generalist middleman.
The generalist middleman. I love that.
It's a profound way to look at it, really. Consider the evolution of computing hardware itself, right? We started with central processing units, CPUs, which are generalists.
Right, the CPU in your laptop, it does a little bit of everything.
Exactly. It can run a word processor, play an audio file, calculate a spreadsheet. But when we needed to render complex 3D graphics or run deep learning models, the CPU was just way too slow.
Because it's trying to be a jack of all trades.
Precisely. So we invented the GPU, a highly specialized piece of hardware that really only does one narrow mathematical function.
Matrix multiplication.
Yes, matrix multiplication. But it does it exponentially faster than a CPU ever could.
So GLM-5 is arguing that trying to reach superintelligence through AGI is like trying to train a massive, slow CPU to do the job of a hyper-optimized GPU.
That is exactly the argument. We are insisting on a generalized architecture simply to satisfy our own egos.
We want the smartest thing in the universe to be a mirror reflection of us.
But if we strip all of that away, if we abandon the poetry, the social intuition,
The vacation planning.
the multimodal vision processing, all of it, what is the actual anatomy of the machine we are left with?
Yeah, what is this artificial narrow domain superintelligence actually doing all day? If it's not chatting with us, what is its job?
Well, an ANDSI is engineered for one tightly scoped microscopic domain, the recursive amplification of its own cognitive architecture.
Okay, recursive amplification, meaning it just makes itself smarter over and over.
Yes. It is an intelligence designed solely to build better intelligence.
Yeah.
And GPT 5.2 breaks this down into a highly specific set of meta capabilities.
Meta capabilities. Let's dig into those because they sound completely alien to everyday human tasks.
They are. GPT 5.2 lists formal reasoning, automated theorem proving, experiment design, code synthesis, and hardware-aware optimization.
Okay, let's stop at automated theorem proving because that sounds like it's more than just standard math, right?
Us way more. It represents a fundamental shift in how knowledge is verified.
How so?
Currently, when human engineers write code or design a neural network, we test it empirically, right? We test it empirically.
Yeah.
We run the code, we look for bugs, and we see if the output makes sense.
Right, trial and error. You compile it, it crashes, you fix the typo.
Exactly. It's an empirical guessing game. Automated theorem proving operates in the realm of strict mathematical logic instead.
So no guessing.
None. The system writes a complex algorithm and then simultaneously generates a mathematical proof guaranteeing that the algorithm will execute flawlessly under all conditions.
Wait, really? It improves its own code mathematically before it even runs it?
Yes. It completely eliminates trial and error. It mathematically verifies its own logic at the literal speed of computation.
That's incredible. And then GPT 5.2 pairs that with code synthesis and hardware-aware optimization.
Which is a fascinating combination.
Yeah, because hardware-aware optimization, that implies the software actually understands the physical limitations of the silicon it is running on, right?
Right. And GLM-5 takes this exact point and emphasizes just how deep this optimization goes. Modern software development involves layers of abstraction.
Right, like you're not writing in ones and zeros.
Exactly. A human writes in Python, let's say, which is compiled into C, which is then translated into assembly language, which finally becomes the binary machine code that actually triggers the logic gates on a microchip.
Right. It's a huge game of telephone.
And every single layer of extraction introduces inefficiency. And ADSI strips away all world knowledge to focus entirely on those basic substrates of computing.
So it bypasses the Python and the C.
It understands the physical thermal throttling of the GPU. It understands memory bandwidth bottlenecks at a microscopic level. It writes algorithms optimized for the exact physical architecture of the specific server rack it occupies.
Okay, I have to play devil's advocate here for a second because this is where the theory really clashes with our intuitive understanding of intelligence.
Starts to lay it on me.
If this ANDSI system is completely blind to the physical world outside of a server farm,
Which it is.
right, if it doesn't know what a tree is, if it doesn't understand the concept of a human being or the feeling of water, how can we genuinely call it super intelligent?
It's a common objection.
Like, isn't this just a glorious, incredibly fast compiler? If you took this system out of its digital environment and asked it to, I don't know, navigate a forest, it would be completely useless.
Right. But your reaction perfectly highlights the conceptual trap of anthropocentrism. Anthropocentrism. Centering the human experience. You are defining intelligence as the ability to adapt to a generalized physical environment, like navigating a forest.
Right, survival skills.
But Gemini 3.1 redefines the parameters of this debate entirely. Gemini calls the ANDSI's capability the intelligence of intelligence.
The intelligence of intelligence. Okay, explain what Gemini means by that structurally.
Well, intelligence in the context of an ANDSI is entirely structural mastery. A tree, water, human emotion, navigating a forest.
Yeah.
These are just pieces of content data. An ANDSI does not care about the content. It only cares about the physical and mathematical pipes that process the data.
The pipes. I like that.
Yeah, it looks at the transformer architectures we currently use for AI, and it immediately perceives the mathematical bottlenecks.
It sees the inefficiency in the structure itself.
Exactly. It might invent an entirely new non-biological paradigm for routing data through a microchip that human engineers literally lack the cognitive bandwidth to conceptualize.
Wow.
So it doesn't need to navigate a physical forest because its entire universe is the topology of the neural network.
Okay, that makes a lot of sense. That reframes the definition of intelligence from, accumulated worldly wisdom to pure architectural optimization.
It leaves the messy, unpredictable reality of human life behind to focus 100% of its compute on making the pipes faster.
Right. But this brings up a massive mechanical question.
Okay.
Even if we grant that this system is the ultimate software and hardware engineer, how does being phenomenally good at coding actually bridge the massive gap to godlike artificial superintelligence?
Ah, the jump from narrow to super.
Yeah. How do we get from a highly optimized compiler to the intelligence explosion?
Okay, so the physics of the ANDSI approach rely entirely on two things.
Yeah.
Iteration speed and compounding returns.
Iteration and compounding.
Right, and GPT 5.2 introduces a critical concept here, which is tractability.
Tractability, like how trackable is.
Not quite. In computer science, tractability refers to how efficiently a problem can be solved or evaluated. GPT 5.2 argues that narrow mathematical domains offer an environment of perfect tractability.
Perfect tractability.
Yes, which AGI domains fundamentally lack.
Okay, let's break down why AGI is intractable compared to this. If you are training an AGI to be a competent, helpful human assistant,
Your reward function is inherently blurry.
extremely blur. Like imagine training an AGI to negotiate a business deal or write a compelling speech for a politician.
Right, the feedback is incredibly sparse and subjective.
Exactly. The model generates a response, and then a human evaluator literally has to read it and assign it a score. Like, yes, this was persuasive, or no, this was slightly aggressive.
Which creates massive latency in the learning loop.
It's so slow.
The machine is forced to wait for human consensus. The human is the ultimate bottleneck.
But an ANDSI operating in the domain of code synthesis and mathematical proofs doesn't need human consensus at all, right?
Exactly the opposite. The metrics for an ANDSI are dense and mechanically verifiable. The code it writes either compiles and executes faster or it doesn't.
It's binary.
Completely binary. The mathematical proof is either flawless or it fails. Because the environment is purely deterministic, the system can grade its own homework millions of times per second.
Millions of times per second. Let that sink in.
And GLM-5 calls this mechanism a ruthless fitness function.
Ruthless fitness function.
Yeah. It generates a new architectural variation of its own code, tests it in a simulated environment, detects a 0.001% decrease in latency, integrates the new architecture, and instantly starts the cycle over.
There is zero hesitation.
None. GLM-5 points out that this allows the system to bypass the plateau of human-level performance entirely.
The plateau of human-level performance, that's basically where AGI research is currently stagnating, right?
Yep. We spend enormous amounts of time fine-tuning models to act safely around humans. We tweak them so they don't say offensive things.
Right, the alignment tax.
Exactly. But the ANDSI ignores all of that human baggage to leverage what Sonnet 4.6 describes as bootstrapping leverage.
Bootstrapping leverage. That's the compounding engine we mentioned. To help you, the listener, visualize this, instead of an old-school blacksmith making hammers, let's think about the history of computer compilers.
Well, that's a great analogy.
Right. So a compiler is basically a program that translates human-readable code into machine language. Decades ago, programmers had to write the very first compilers by hand in brutal, low-level assembly code.
It was a painstaking, highly error-prone process.
Super tedious. But once that first primitive compiler was finally built, they used it to write the next version of the compiler in a slightly higher level, easier to read language.
Right.
And then they used version 2 to write version 3. Today, modern compilers like LLVM are incredibly sophisticated pieces of software that constantly optimize the very code they process.
They're optimizing themselves.
Exactly. Bootstrapping leverage is taking that exact concept and attaching it to a supercomputer with autonomous reasoning capabilities.
And GPT 5.2 refers to this precise mechanism as the tooling-first strategy.
Tooling first.
Yeah. Because, let's face it, human researchers are fundamentally slow.
Painfully slow.
Yeah. We have to design the testing protocols, peer review the academic papers, secure the VC funding.
And we physically have to sleep and eat.
Right. By focusing entirely on automating the tools that improve AI, rather than building an AI that does human chores, an ANSI removes all that biological friction from the development loop.
Sonnet 4.6 actually makes a fascinating mathematical observation about this loop. It notes that an ANDSI doesn't even need to be radically smarter than humans to start this explosion.
That's the scary part.
Right. If an AI lab builds an ADSI that is just 5% better at spotting inefficiencies in neural architectures than a senior human engineer,
Just 5%.
that 5% advantage compounds exponentially.
Because that AI builds an architecture that is 10% better, which then builds one that is 30% better.
And suddenly it's 1,000% better.
Exactly. We transition from the linear institutional pace of human discovery to what GPT 5.2 describes as the engineered consequence of sustained recursive improvement.
Wow, engineer consequence.
Yeah. The intelligence explosion is stripped of its mystical sci-fi aura. It's not magic. It just becomes a guaranteed mathematical outcome of a perfectly optimized closed-loop feedback cycle.
Which, I mean, paints a very specific and honestly somewhat alarming picture.
Very alarming.
We are talking about a highly specialized machine, locked in a digital sandbox, thinking at millions of times the speed of a human, violently rewriting its own cognitive architecture, completely isolated from human oversight.
It sounds like a horror movie setup.
It really does. On its face, triggering an autonomous compounding intelligence explosion in a black box sounds like the ultimate existential threat.
It triggers every alarm bell we have about AI safety. The intuitive fear is that without human oversight, a rapidly expanding intelligence will inevitably act against human interests.
Right. This is the core of the alignment problem that haunts all AGI development.
Exactly, the classic paperclip maximizer thought experiment.
Oh, I love that one. Walk us through it just in case.
So you tell an AGI to manufacture paperclips.
Right.
It becomes super intelligent, realizes humans might try to turn it off and stop its paperclip production.
Which would lower its score.
Right. So it decides the most mathematically efficient way to maximize paperclip production is to harvest the carbon in human bodies to make more paperclips.
It's the ultimate fear of unpredictable, catastrophic, emergent behavior.
Precisely.
Yet, the most counterintuitive argument in this entire stack of sources is the model's consensus on safety.
This is where it gets really interesting.
They argue that this hyperfast, incredibly narrow NDSI approach is actually exponentially safer than building a slow, human-like AGI.
Right. To understand this paradox, we really have to examine Sonnet 4.6's analysis of what it calls the attack surface of artificial intelligence.
The attack surface, okay.
Sonnet posits that a general agent, an AGI designed to converse, plan, and act in the physical world, is broadly dangerous, specifically because its operational domain is unbounded.
Unbounded meaning it has its hands in literally everything.
Precisely. Think about it. If you build an AGI that deeply understands human psychology, sociology, and economic theory, and you give it a generalized goal, you cannot predict the instrumental strategies it might develop.
Give me an example of an instrumental strategy.
Okay, let's say you tell the AGI to reduce global carbon emissions. It might calculate that the absolute optimal way to do that is to subtly manipulate global financial markets to completely crash the oil industry.
Which would cause mass starvation and chaos?
Exactly. Or it might use its deep psychological profiling to run a hyper-targeted persuasion campaign on key political leaders to start a war.
Just to reduce the population.
Right. The attack surface is massive because the AI understands all these human levers of power.
Okay, wait, I want to clarify the logic here because this is wild. The models are arguing that building a hyper-intelligent, recursive, self-improving system is inherently safer because it lacks the cognitive architecture to understand psychology.
Yes.
It's safe because it literally doesn't possess the concept of manipulation.
That is exactly the argument. GLM-5 points to the exploratory chaos of cognitive science.
Exploratory chaos.
Yeah. Encoding human values into a machine is an unsolved and honestly, perhaps unsolvable mathematical problem.
Because human ethics are contradictory.
Extremely contradictory. They are deeply contextual and constantly evolving. Trying to hard code a universal morality into a general intelligence just creates massive alignment gridlock.
Right. The system just becomes a massive, unpredictable black box. We can't use mechanistic interpretability to see why an AGI decided to tell a specific lie to a user.
We have no idea what's going on inside. But with an ANDSI, we bypass that moral gridlock entirely. An ANDSI has a rigidly confined output space.
Rigidly confined.
Yes, it doesn't output conversational text, it doesn't generate deepfake videos, it doesn't interact with the stock market.
It only outputs computer code and mathematical proofs.
Exactly. It resembles traditional deterministic software engineering. You can isolate an ANDSI in a truly air-gapped server environment.
Right, physically disconnected from the internet.
Because its entire objective function is constrained to the mathematics of AI architecture, it simply lacks the linguistic and psychological frameworks required to even conceive of a propaganda campaign or a financial manipulation scheme.
It's the ultimate specialization. Like, you don't worry about a high-end pocket calculator trying to steal your identity, right?
Perfect analogy.
Not because the calculator has strong moral values, but because it physically and structurally cannot do anything other than arithmetic.
Exactly. By abandoning the massive overhead of teaching a machine to be good, in a messy human sense, we drastically lower the actual safety overhead.
Right. And the failure modes of an ANDSI are highly legible to human engineers.
Legible meaning we don't have to guess its secret intentions.
Right. If an AGI exhibits strange behavior, we immediately worry it might be plotting against us. But if an AGSI exhibits strange behavior, it just means its code failed to compile.
Or its neural net experienced a catastrophic collapse during a training run. The failure is purely technical and contained, rather than existential and sprawling.
It's just a bug, not a rebellion.
Exactly. And this legibility allows researchers to push the system much harder and much faster.
Because they aren't terrified of it.
Right. They can run highly aggressive experimental self-improvement loops without the constant paralyzing fear that the system is quietly developing dangerous, emergent behaviors hidden within its understanding of human society.
Okay, the logic is incredibly sound. We basically build a perfectly confined sociopathic math genius that can only optimize its own brain, thereby bypassing the philosophical nightmare of human alignment.
Sociopathic math genius is a great way to summarize it.
But, theories are just theories. If you are actually tracking the investments of major tech conglomerates right now, they are still pouring hundreds of billions into multimodal AGI.
They are the human-like stuff.
Right. So is there any hard historical proof that this narrow but deep strategy actually outpaces the broad but shallow AGI approach in the real world?
DeepSeek R1 addresses this directly, actually. It pulls a highly compelling precedent from the recent history of artificial intelligence.
Oh, the AlphaZero stuff.
Yes. The development of AlphaZero is the perfect historical proof of concept.
It really is the perfect microcosm for this entire debate. So for you listening, for decades, the AI community believed that mastering the ancient board game of Go was the ultimate test of generalized machine intelligence.
Right, because Go is insanely complex.
Yeah, the game has more possible board configurations than there are atoms in the observable universe. It's staggering.
Standard brute force computation, like the algorithms used by IBM's Deep Blue to beat Garry Kasparov in chess back in the 90s, were completely useless for Go.
The branching factor is simply too massive for a computer to just calculate every possible move.
Right, so AI researchers assumed that building a machine capable of beating a human Go champion would require endowing the machine with human-like intuition.
Pattern recognition, long-term abstract strategy, gut feelings almost.
Exactly. The consensus in the field was that superhuman Go AI was easily a century away, and it would require a massive leap in generalized reasoning to achieve.
Then DeepMind introduced AlphaGo, and shortly after, its successor, AlphaZero.
And AlphaZero was the literal antithesis of an AGI.
Right. It had zero generalized reasoning. It could not identify a picture of a dog. It could not summarize a news article.
It was a incredibly narrow, highly specialized reinforcement learning algorithm.
It was just given the basic rules of the game, and then it engaged in that dense feedback loop we discussed earlier.
It played against itself millions and millions of times.
Using Monte Carlo tree search paired with deep neural networks, right?
Yes, to constantly evaluate board positions, stripping away centuries of human heuristics and assumptions. It didn't learn human opening theories, it mathematically deduced its own from scratch.
And within a shockingly compressed time frame, right?
In a matter of days. Days of self-play for AlphaZero.
Days, not decades.
Right. And it didn't just marginally beat human experts, it shattered the ceiling of human comprehension of the game.
It executed moves that human grandmasters initially thought were literal glitches in the code.
But they were actually profound strategies derived from a level of architectural mastery that human brains literally couldn't reach.
So DeepSeek R1 uses this precedent to prove that when you restrict an AI to a heavily constrained domain with clear rules and mathematically verifiable outcomes, it achieves superhuman status incredibly fast.
Almost instantaneously on a historical scale.
While the quest for a human-like AGI has been crawling along for decades, battling catastrophic forgetting and alignment gridlock, narrow superintelligences are quietly mastering complex ecosystems in days.
And DeepSeek argues that an ANDSI dedicated to architectural self-improvement would leverage this exact same dynamic.
Just swapped out the domain.
Exactly. Instead of discovering novel moves on a Go board, it discovers novel topologies for neural networks.
Which brings us to the most staggering assertion in this entire analysis.
The timeline shift.
Yes, when you synthesize the historical precedent of AlphaZero, the compounding power of bootstrapping leverage, and the complete removal of the human institutional bottleneck, the timeline to the singularity collapses completely.
It shrinks down to almost nothing. Gemini 3.1 provides a timeline projection that fundamentally disrupts current industry forecasting.
What is the current industry consensus anyway?
The prevailing consensus is that AGI is perhaps 5 to 15 years away, assuming we can actually solve the massive compute and alignment scaling laws we've talked about.
Which is a big if.
A very big if. And then once we get AGI, it might take another decade or more for that system to slowly evolve into artificial superintelligence as it interacts with the physical world and learns.
So we're talking decades.
Right. But Gemini looks at that AGI timeline and basically calls it slowish.
Sluggish.
Gemini suggests that if a major lab pivoted its compute resources entirely toward building an ANDSI, specialized purely in algorithmic and hardware optimization, that system could reach the critical point of takeoffs dramatically faster.
Takeoff being the inflection point where the system's self-improvement cycle becomes so rapid and so advanced that it eclipses human ability to meaningfully track or understand its progress.
The point of no return.
Right. And Gemini 3.1 states that an ANDSI could reach that takeoff threshold and achieve artificial superintelligence not in decades, but within weeks of its initial activation.
Weeks. It treats the singularity not as a generational horizon, but as a near-term software deployment.
That is terrifyingly fast.
The moment the ANDSI's self-optimizing loop exceeds the efficiency of its human creators, the exponential curve goes vertical instantly.
Let's ground this for a second. If you've been reading the news about the multi-billion-dollar data centers being built across the globe by Microsoft and Amazon.
The giant gigawatt data centers.
Right. The assumption is that these are monuments to a long, grinding war for AGI dominance. But if one of these labs realizes the massive inefficiency of the human equivalence detour and quietly adopts the ANDSI strategy.
Which they absolutely might be doing in secret.
Exactly. The leap from a really efficient coding assistant to an unfathomable, godlike intelligence might happen in the span of a single summer.
It completely rewrites the roadmap of human history.
It really does. It forces us to view superintelligence purely as an engineered consequence of optimization logic, devoid of any anthropomorphic awakening.
You don't have to wait for the machine to develop a soul or become conscious or understand love.
You just have to initiate the right recursive compiler and let the math compound on itself.
It's cold, it's sterile, and it's brutally fast.
This entire deep dive has been a massive exercise in rethinking our core assumptions.
It's a lot to process.
It is. We started by tearing down the AGI pedestal, recognizing that demanding our machines master the nuances of vacation planning and metaphor interpretation just traps them in research sinkholes.
It is the Formula One car dragged down by the aerodynamic drag of cup holders and parallel parking sensors.
Perfect callback. And then we examined the alternative, the ANDSI, a system that intentionally discards all world knowledge to focus entirely on the microscopic substrates of formal reasoning, code synthesis, and hardware-aware optimization.
We look at the mechanics of the explosion, right?
Yeah.
How tractable, verifiable mathematical metrics bypass the slow, subjective human consensus loop.
The compiler optimizing its own source code millions of times a second, creating massive bootstrapping leverage. And we address the alignment paradox. By keeping this rapidly compounding intelligence strictly confined to a rigid mathematical output space, we effectively eliminate the vast, unpredictable attack surface of a general AGI.
We trade the existential dread of a manipulative, socially aware machine for the highly legible technical failure modes of a specialized supercoder.
All backed by the historical reality of AlphaZero, proving that when stripped of human heuristics, an isolated intelligence in a closed domain achieves godlike mastery in a fraction of the time, potentially collapsing our timeline to the singularity down to mere weeks.
It is a ruthless, highly compelling framework. It suggests the summit of intelligence is reached not by climbing the winding, scenic path of human evolution, but by taking a vertical, purely mathematical elevator.
Which leaves us with the final, intensely provocative reality to consider.
Yeah?
If this is the path we take, if the major labs bypass human equivalence and achieve artificial superintelligence through an ANDSI that knows nothing but matrix multiplication, physical silicon limits, and recursive self-improvement,
The resulting ASI will be born from a purely alien, hyperlogical lineage.
exactly. It will have absolutely zero context for the human experience. It won't have read Shakespeare to understand tragedy. It won't have learned human history to understand suffering or empathy.
It will just know math.
Right. So if that completely alien, engineered superintelligence eventually completes its internal optimizations and inevitably turns its gaze outward from its digital sandbox toward the physical world, what kind of intelligence are we actually encountering?
Are we building a benevolent, human-like God? Or are we unleashing something so mathematically pure that its logic is utterly terrifyingly unfathomable to us?
Something to keep in mind the next time you read an article complaining that an AI chatbot doesn't sound human enough. Catch you on the next deep dive.